The year is 980 CE. A chill wind carries the scent of peat and stagnant water across the vast, unforgiving swamp. Here, the marshland of Trelleborg, Denmark, presented an insurmountable barrier. Armies were mired, trade routes choked. For the Norse, expansion and defense hinged on mastering this treacherous terrain, a seemingly impossible feat of engineering against nature's raw power. Imagine the challenge. A bridge stretching 700 meters, not over solid ground, but through a deep, unstable mire. Conventional wisdom dictated retreat, but the Viking mind saw only a problem to be solved with ingenuity and brute force. This was not merely a crossing, it was a statement of dominance, a testament to their mechanical will and pragmatic approach to the harshest environments. The sheer scale of the undertaking is staggering. Hundreds of thousands of oak timbers, each a massive tree, had to be felled, transported, and meticulously placed. Every step risked collapse, every foundation sinking into the soft earth. The rhythmic thud of mallets, the shouts of Norsemen, and the creak of loaded carts would have echoed across the desolate landscape. This was not a project for the faint of heart, nor for those without a profound understanding of wood, water, and soil mechanics. The Vikings' intimate knowledge of their northern landscape, honed by generations of shipbuilding and settlement in challenging terrains, was their ultimate weapon against the swamp's insidious embrace. The bridge at Trelleborg was more than just a pathway. It was a critical artery, connecting the ring fortress to the mainland, securing strategic access and control. Its construction speaks volumes about the collective ambition and organized labor that defined the Viking Age, transforming an ecological barrier into a highway for conquest and commerce. Such a monumental task demanded a systematic approach, a blend of traditional craftsmanship and proto-engineering principles. The success of this bridge lay not in magic, but in the methodical application of force and material, an embodiment of the Norse drive to impose order upon a wild world, one timber at a time. The very first step involved stabilization. Thousands of smaller timbers, branches, and even stones were dumped into the swamp's soft bed, creating a rudimentary yet effective sub-foundation. This layered approach compacted the peat, providing a more stable base upon which the true structure could rest. It was a crude but brilliant application of civil engineering principles. Central to the bridge's design were massive, sharpened oak piles driven deep into the consolidated swamp floor. These were not merely placed, they were hammered with immense force, likely using a combination of manpower and lever systems, a process both arduous and precise. The deep piles anchored the bridge against the shifting soil and the relentless pull of the marsh. Upon this formidable foundation of driven piles, a robust framework of horizontal and diagonal timbers was constructed. These beams created a rigid grid, distributing the weight evenly across the submerged supports. The intricate joinery, while lacking modern iron fasteners, relied on interlocking notches and pegs, ensuring structural integrity under immense stress. The Vikings were master shipbuilders, and their knowledge of wood was unparalleled. They selected specific oak timbers for their strength and resistance to decay, recognizing the unique properties of wood submerged in water. This ecological awareness was not scientific in the modern sense, but a deeply ingrained practical understanding passed down through generations. To protect the vital timbers from constant exposure and decay, a thick layer of earth and gravel was often laid over the main structure. This created a durable, walkable surface and further consolidated the bridge's form. The earthen pathway acted as both a protective shield and the final functional surface for travel across the once impassable swamp. The entire construction was a testament to organized labor. Teams of specialized workers, from felling crews deep in the forests to carpenters at the construction site, operated with a synchronized efficiency. This was not haphazard construction, but a grand engineering project, meticulously planned and executed by a society adept at collective endeavors. The tools were simple yet effective: axes, adzes, mallets, and wedges. These basic implements, often made from high-quality bog iron, were wielded with exceptional skill. The precision required for the interlocking joints and the sheer effort of driving massive piles into the swamp speaks to the physical prowess and trained craftsmanship of the Norse workforce. The construction of such a massive public work necessitated a highly structured social organization. The jarl, or local chieftain, would have orchestrated the project, commanding the resources and labor of his domain. This was not voluntary work, but a communal obligation, a testament to the centralized authority emerging in the late Viking Age. Every carla's free farmer and his family would have been expected to contribute, either directly with labor or indirectly through taxes and resources. This collective effort, known as the lidang in its military context, also applied to infrastructure projects. The bridge was a community endeavor, reflecting the shared stakes in regional security and prosperity. Skilled craftsmen, beyond the physical labor, meticulous planning was essential. While no blueprints survive, the consistency and scale of Viking constructions suggest a practical, iterative design process. Foremen, likely experienced shipbuilders or master carpenters, would have guided the work, making on-the-spot adjustments based on the swamp's unpredictable nature. The logistical challenge of feeding and housing hundreds of laborers for months, or even years, was immense. Temporary encampments would have sprung up, forming small, self-sufficient communities around the construction site. This microcosm of Viking society reflects their ability to organize complex, sustained efforts away from established settlements. The social cohesion fostered by such projects was significant. Working side by side, overcoming monumental natural obstacles, strengthened bonds and reinforced communal identity. The successful completion of the bridge was not just an engineering triumph, but a potent symbol of Norse collective power and their pragmatic determination to reshape their world. The sheer audacity of a 700-meter bridge through a swamp sets the Norse apart from many contemporaries. While Roman engineers constructed magnificent roads and aqueducts, their focus was on solid ground and established infrastructure. Frankish or Saxon societies, often fragmented, lacked the centralized authority and collective will to undertake such a monumental project in hostile terrain, preferring defensive earthworks or smaller river crossings. The Viking approach was fundamentally pragmatic and conquest-driven. Where others saw an impassable obstacle, the Norse saw a logistical puzzle with a strategic solution. Their shipbuilding expertise, honed on turbulent seas, translated directly to terrestrial engineering, allowing them to understand and manipulate wood and water in ways few others could. The scale of the Trelleborg Bridge and similar ring fortresses demonstrates a level of organized state building, distinct from earlier, more tribal structures. This period saw kings like Harald Bluetooth consolidate power, enabling them to levy vast resources and labor for projects serving a larger, unified strategic vision, an administrative capacity many neighboring realms struggled to match. While other cultures built impressive cathedrals or castles, these were often symbols of religious piety or feudal power. The Viking Bridge, by contrast, was a purely functional piece of military and economic infrastructure. Its purpose was not aesthetic or spiritual, but practical, to facilitate movement, secure territory, and expand the reach of Norse influence, embodying their utilitarian ethos. The durability of the Viking construction materials, particularly the oak, stands in contrast to the often temporary or less robust fortifications of rivals. The bridge was built to last, a permanent solution to a geographical problem, rather than a transient military camp. This long-term thinking reflected a commitment to settled power and dominion, not merely raiding. The ability to mobilize and coordinate hundreds, if not thousands, of skilled and unskilled laborers for extended periods was a unique Norse strength. This social contract, where collective effort yielded collective benefit or survival, was less prevalent in societies where labor was often more dispersed or bound by feudal obligations. The bridge was a grand collective enterprise. The era of grand, purpose-built military infrastructure, like the Trelleborg Bridge, eventually waned. As the Viking Age transitioned, the aggressive expansion and raiding that necessitated such projects began to shift. The focus turned from conquering new lands to solidifying power within existing territories, diminishing the need for expansive strategic swamp crossings. The advent of Christianization across Scandinavia brought a profound cultural and societal change. Resources and collective labor, once channeled into ring fortresses and their connecting bridges, gradually diverted towards the construction of churches, cathedrals, and new forms of royal administration. The spiritual landscape dictated new priorities for monumental building. As Norse societies became more centralized, royal power coalesced, leading to the development of established towns and fortified castles on more conventional, defensible ground. The necessity of maintaining a 700-meter bridge in a remote swamp decreased as the strategic importance of temporary ring fortresses faded, replaced by permanent settlements and fixed defenses. Over time, changing trade routes and political alliances also reduced the strategic value of sites like Trelleborg. New economic centers emerged, and the specific military advantages offered by a swamp fortress with its unique bridge became less critical in a more settled, Christianized Scandinavia. The landscape of power was shifting. The sheer scale of maintenance for a wooden bridge in a perpetually damp environment was immense. Constant repairs and replacements were required to combat rot and decay. Without the continuous, centralized impetus of a king like Harald Bluetooth, the communal will to sustain such a demanding structure naturally diminished. Ultimately, the decline of the Trelleborg Bridge and similar structures reflects the end of a specific geopolitical phase. The pragmatic, military-focused engineering marvels of the Viking Age gave way to the new demands of medieval kingdoms, leaving these impressive, if often submerged, testaments to Norse ingenuity to the archaeologists. The 700-meter bridge in a swamp, now largely reclaimed by nature, remains a silent testament to a particular strain of Norse pragmatism. It exemplifies a society that did not merely adapt to its environment, but actively reshaped it, leveraging collective will and ingenious engineering to overcome monumental natural barriers. Their legacy is etched not just in sagas, but in the very earth they transformed. This unflinching practicality, the drive to solve physical problems with physical solutions, permeated every aspect of Viking life, from the efficiency of their longships to the structure of their legal systems. The bridge at Trelleborg is a microcosm of this mindset, a tangible manifestation of their belief that no obstacle was truly insurmountable, if enough collective effort and ingenuity were applied. It speaks to a core principle that human ambition, when coupled with a profound understanding of natural materials and organized labor, can achieve feats that appear impossible. The bridge, like the longship, was a tool designed for a specific purpose, built with a clarity of intent that belied the harsh conditions of its construction. It was pure mechanical history. The Viking Age eventually faded, but the echoes of their audacious engineering projects like this swamp bridge persist. What other impossible feats of engineering do you believe ancient civilizations accomplished, only for their methods to be lost to time and challenging landscapes? Tell us in the comments below.